Okay, welcome to Austin Elixir for June 20th, 2016. I am Luke Imhoff. I'm a senior software engineer at Communication Service for the Deaf, or CSD. CSD is a fully remote company right now. We are transitioning. The development team's been fully remote for a few months now, and it's great. The rest of the nonprofit is slowly moving to fully remote because it turns out nonprofits like to share save costs, and not having to have an office is kind of a good cost saver. It also lets us be very flexible. We can all move around, for our own costs. And the only people that really need to work anymore non-remotely is our call centers. I personally work on Vinya, which is a marketplace. You can go to govinya.com to see the previous iteration of it. And that's a marketplace, and we're also working on a SaaS to allow intervening agencies to use the same technology we use for the marketplace internally on their own. The nice thing about Vinya is it allows the deaf community to pick out their own interpreters, which wasn't the case previously. It used to be that they had to go through an agency or even go indirectly by asking a business to get them an interpreter, and then the agency would get through that business, and this way they have much more choice. So it's really helped the community. For the current version of Vinya, it's a Ruby application, and for the next version, we're doing a mix of Ruby and Elixir. In my free time, I'm the maintainer of the IntelliJ Elixir plugin. You may have seen the most recent release that looks like Rainbow Sherbert. When I know, oh, hello, are we not linked anymore?
Yeah, I have video on my screen.
No, this one isn't linked though. This one didn't advance.
The screen's on the same as
okay. Let me just close my speaker notes and restart that one.
The screen. Yeah, nope, there it is. But it's got a delay. Yeah, it took a while to catch up, but now it's actually.
Okay.
It seems to be keeping.
So now my speaker notes are linked. Okay. When I announced the release of Alembic, there were multiple people wondering how it compared to JAWSerializer, which was a pre-existing library for JSON API. But for Vinya, we use JAWSerializer with Alembic. Oh, and if anyone thinks, why Alembic? It is an Elixir poison joke. Alembic is one of the alchemy set things that you can use in Elder Scrolls. We use JAWSerializer's plugs to deal with the content type negotiation and the deserializer, which JSON API just likes to have any underscores in params actually be hyphenated, so they look more URL-like. And what the deserializer does is just turns them back into underscores. So they're more used to the params that we're used to working with in Rails and Ecto. Once inside each action, through steps 4 through 8, we use Alembic to transform the raw JSON params into a JSON API document and make sure that it really is a JSON API document and follows the spec. Then if it does follow the spec, we use 2 params to convert into the type of params that Ecto would use. We use nested foreign key to make sure that any belongs to keys are set up correctly. And we then use the 2 fetch calls from params and 2 preloads to convert from the includes directive that JSON API supports to the preloads that Ecto supports. And then finally, we jump back to JAWSerializer and its Phoenix View support, which allows us to, with the DSL, to declare how to re-render JSON API documents. So right now, since April 2016, JAWSerializer has pieces similar to this. They have a thing called params2attributes. But params2attributes just extracts attributes out of your JSON API document. It doesn't actually check that the document is valid for the parts you don't care about. And JSON API, because it's an encoding meant to be machine readable and to be very helpful for like, you submitted it wrong, here's the errors to fix what you're doing wrong. It's very clear that you should give helpful errors whenever possible. And that was part of the point of Alembic, was I wanted to give helpful errors whenever possible because on the Ruby and Rails side, we're using a very, very well-tested, very close to the spec library called JSON API resources. If you have to do Rails with JSON API, I could not recommend it more. It follows every single place where you can check that your document follows the spec. It does. It is very helpful when you don't know what you're doing with JSON API to tell you, you did this wrong and here's how you fix it. Yeah, so I wanted that level of helpfulness when doing JSON API from interpreter from our Elixir app, because I wanted those. What? JavaScript Elixir was the big one. I think there's one called JSON API, and what are the other two? Yeah. Oh, okay. Another thing I wanted to have with I wanted the errors automatically created so that they were normal, because the JSON API spec says here's an error object and you can use these fields, but it doesn't say how you use those fields. And I wanted to make sure that those fields were used consistently across all our errors so that the Ember apps and the calling apps in Ruby over RPC could depend on those formats if they needed to. So the entry point when you're parsing the JSON params is Alembic documents from JSON. JSON is just the set of params that come in with the underscores already created. And then we give it an error template as the second argument. And that has some metadata that says, what action are you running and who sent it? So the sender could be either the client or the server. So this does work client-side, which we'll get to at the end of the presentation. And then the source, which is a source pointer. Source pointers are an actual RFC that the JSON API docs reference. And it's just says in JSON, how do you reference an element inside of a nested JSON struct? And it does the difference between, like, how do you say this element is screwed up or a child of this element is screwed up? And it's very clear about, does a trailing slash matter and that sort of thing. So it disambiguates those arguments you could have about how to interpret paths in a JSON document. Here, it's important that the action is create, because the JSON API spec allows certain parts to be optional for create. So like, you don't have to pass the ID on create, but everywhere else you would have to pass the ID. JSON API actually allows you to pass the ID on create if you want, because it allows client-side creative IDs if you use UUIDs. And that's mostly to allow more distributed creates, because it assumes the UUIDs won't collide, so then you don't have to have a synchronized database in the background. If you pass this function an empty document, which would be where data is nil, all it does is turn it into a struct. So not very interesting. It says OK, so it says it is actually following the document. In general, this is how Alembic works, is if the spec gives a predefined set of keys you can have, it's going to turn into a struct to say this is predefined data, you can trust the format. If it's something where it can't do a predefined set of keys, it's going to keep it a string so that you don't get atom table exhaustion. If you actually do have data, then it's going to put that into a resource. So JSON API has two things. It has resources with attributes or relationships, and then it has resource identifiers, which is just like a pointer to data somewhere else. And so that just has an ID and a type. So here you see the resource identifier with only the ID and type. Unfortunately, there's no type hints. So like this, you see there's ID and type. But, oh, went the wrong way. And here, there's type but no ID. But if this wasn't a create, ID could be there. So what I had to do in the library is just kind of make the heuristic of, if you see attributes or you see relationships, it must be a resource and not a resource identifier. So it almost seems from like an inheritance perspective that a resource is a subclass of a resource identifier, but we don't have subclassing in Elixir, so I kept them separate structs. And I didn't want to do this where like every resource identifier is actually a resource where the attributes or relationships are missing, because they have to be handled differently. And so it's much easier to match on the struct if I keep them separate and make the decision at this point. This I did this sort of from the advice that a lot of the blogs from the older Erlangers talk about, or that Jose himself has said, were like, you should make sure the data you're entering the system is good on the boundary, and after that point, you should be able to trust it. And that's part of this of like, I should make the decision whether it's a resource identifier or a resource as early as possible, and then after that, depend on that decision. JSON API can also do collections. And so you would get a collection for like a has-many association or for like an index view. So the show would have a single piece of data with one resource, and the index view instead would have a list. So when it's converted over, we're still using a simple list. We're not transforming it to do like a lookup by ID or type or anything like that. And then we're just turning into a struct. The most complicated form of a JSON API document is when you start to get relationships. The JSON API spec considers foreign keys and implementation detail. It specifically says do not include them in the attributes. So instead what you do is you have a relationship, you give it its name, and here you can see that the comments relationship remains a string once converted because that is not part of the predefined spec. That is something about your resources that it has a comments relationship. So I don't atomize that because that could lead to resource atom exhaustion. So when you have a relationship and a resource identifier, you can't actually tell the difference between it has one or it belongs to. It could be either, and they just refer to that as a 2-1 relationship. They don't say which side of the binding you're on. So part of Alembic was, of course, to handle errors. So here I pass it params that are completely empty. And it actually tells you, details, hey, you need to have data, errors, or meta. So it is possible in JSON API to have a document that comes back and only has a meta top level key. This is mostly because you can include implementation details in meta. Like if you want to, you could say who generated it maybe, or stuff like that, when you would normally have an empty response. So meta is always allowed. Data and errors are exclusive. You either have an errors document with an errors key, or you have data with a data key. And that's actually handled from JSON. It'll actually say, hey, you have data and error set. That's not right. It both catches it ingested from JSON and in the poison encoder implementation that if you try to encode a document, it won't let you encode an invalid document. Because the struct itself can't do that validation, so I do the validation at the encoder time. So one thing I want to make sure with the errors, because this has annoyed me before in a lot of libraries, is you get a human readable error message, and then you end up machine parsing the human readable error message to get data back out. So the details here are the human readable part. But then in meta, because it's freeform, what I did was every single machine parsable element of the details message, the data, errors, and meta is wrong, I have those pulled out in children and list them in a list so that anyone could machine parse this and either do a translation or just generate whatever message they want to do on their own, or maybe even have logic to be like, oh, this is the type of message I need to resubmit with other data. I also set the status, which is like an HTTP status, which is both good and bad. So we use JSON API over JSON RPC for the RPC part, and there's parts of JSON API that totally assume you're over HTTP, which is unfortunate. But we still fake the status even though we're over RPC for some of our usage. We can even go farther and do nested errors. So here, the top level errors key is OK, but the value isn't. It's not a JSON object. It's just a string, which isn't allowed. So then we start using the JSON pointers, where we see the pointer here is no longer the just quote. It actually says /errors. And the way we're able to do that is because I made from JSON a behavior. And so every point where there's a nested structure, or that would be like a special class in a different language, there's a module that says this is how I parse this level of the JSON object and its values, and it supports the from JSON behavior. And so it can either return OK and a map in the or a struct, maps when the keys are not defined by the spec, struct when they are, or otherwise it can return an error with an Alembic document containing errors. So this was tricky to implement because the document parser can potentially return an error that is a document. So there's a little bit of a circular dependency that I had to work around when building this. Oh, I didn't mention, but most of these are actually from the docs. So all these examples, most of Alembic is tested with doc tests. Like the vast majority. The only part that has normal XUnit tests that aren't doc tests is I took every single piece of example code on the JSONAPI.org website and made sure I could parse it and both encode it and reparse it. So I made sure that it was an idempotent parsing, that I didn't accidentally add or drop fields. And my desire to do that went back to how well tested JSON API resources was on the Rails side. Like I wanted to have a library that well tested to make sure that I wasn't building a library that worked for our use case of JSON API, but not the actual spec. Because each level supports from JSON, it needs a way to compute the pointer to its children. So I made a thing, Alembic errors descend, that takes the old template for the parent, says, how do I get to the child? So here, for a collection of data with a list, I'm saying I'm taking element 1, which would be the second element because they're 0 indexed, and it just spits out the new pointer. That way I can keep adding on to the errors and just descend down the tree and say, okay, now you're this place, you're this place, you're this place. On top of that, I need to be able to merge errors together. The reason I want to merge is because I want the errors to work like validation errors, where you see all of them at once. The actual spec says a server may choose to stop processing as soon as a problem encountered, or it may continue processing and encounter multiple problems. I want them all on one request because from prior open source libraries, it always annoyed me when you hit one exception, fix it. Hit one exception, fix. And you have to keep cycling over and over when you're experimenting. And so I want as many errors as possible available. So merge lets me merge 2 errors together. It even goes farther than that, in that merge actually works that if you have an OK document tuple and you merge an error, it then becomes an error. So it stays in the OK state until it hits the first error. And then after that point, it keeps merging errors. And I wanted to know if this had some cool functional programming name. And I guess Scala has a thing like this, and it's called an applicative functor that isn't a monad. Which all it is that's just what like a collection of validation errors is called. But it's funny if you do it the other way. So merge just merges 2 things, but reduce does that across all the data. So like that's where I was talking about. It goes okay, 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 first error. Then it can be okays or errors, but it only collects the errors. The reason why it keeps going is because you want to collect as many errors as possible. So it doesn't stop on the first error. And so the error I showed before where it said, hey, you don't have meta errors or data is this validate minimum children here at the bottom. So you've seen how the library works internally. How do we actually use it in our code? So after JOS serializer deserializer converts the hyphens to underscores, we get our params in our create action. In interpreter server, which is the Elixir app for Vinya, I've made a module here, controller ecto, that does common controller actions for ecto models. I want to do this because part of the thing behind JSON API is that it's a common API no matter what the servers are in. But I'm like, if I'm going to generate the same output no matter what the format, I might as well make the controller actions the same and just have less boilerplate code. And this would also stop the team from inventing new actions. You know, you do REST, and then all of a sudden you're adding new actions instead of making a new resource in REST. That happens a lot. So this is kind of like, well, we have these actions that work really well if you follow the rules of JSON API, and this stops us from inventing actions when we don't need it. So far, the only thing we've had to do is special handling for uploading images, because JSON API really has no concept of that. The best you can do is you could include a URL and then fetch it later, but there's no like direct upload of images because there's just no binary encoding built into it. The general structure I took with this is what I've started calling happy path width. So this width only proceeds if it passes, which is, but more importantly, like this is the happy path. Like I pass authorization, I get a valid change set, I get well-formatted preloads, I pass the next level of authorization, and I properly insert the data. And how all the errors are generated then is each one of these functions knows how to format its own error so that the main happy path doesn't have to see how to generate errors. For this, we're going to focus on valid create change set and preloads from includes on 73 and 74 because that's the part that uses Alembic. So valid create change set calls create change set on line 337, and that on line 217 calls document from JSON, which we'll dive into next. Document from JSON is where we finally call document from JSON from Alembic. So we use the standard error template, but here we pass in the action. This works because the action is either going to be create or update. It wouldn't work in some other cases because JSON API action names don't exactly map to the action names we're used to in Phoenix. But almost, they almost do. And so here you can see that this is actually a reverse width. So this width is actually passing if there is an error. Because remember, this function is handling the error rendering. So if we get an error, then we render the JSON of an unpossible entity with the document. And that document, because it came from error, it's not the partial document that worked. It is an actual error document saying, here's all the validation errors where you screwed up the JSON API format. But if this width fails, and the first line doesn't, the first arrow doesn't match, then it is actually returning OK document and proceeding in the happy path from further up. So like if it passes, then line 217 is also going to pass on this page. So like I was saying, the actions for JSON API are always almost the same as action names in Phoenix and Rails. It's create, delete, and update, but fetch. In the actual docs, they call fetching for both show and index. I think this is mostly because you also can directly ask for a relationship, which would look like an index view, but it's not. It's just viewing a collection. So you can view collections that aren't an index view in JSON API. As far as you can tell, those extra things like showing related items or showing relationships are used by Ember data if you implement them, but they're not required. So they mostly just require the standard show, update, create, delete, and index views, or actions. When document from JSON returns, it'll only pass this part of the width on 217 if it was OK document. If that's the case, we have a document, but we need to make it in a format that we can insert with ecto. So we're going to use ecto2 params to convert it to nested params format, but that won't handle belongs to in associations, and I'll get to that in a sec. So then after that, we pass it to 2 params, which is also, so the full name is Alembic 2 params nested before keys, and that then gets the ecto schema module. So this is 2 params. A JSON API document is at most 2 levels deep. It has the resources and data, or a collection of resources, and then any direct or indirect relationships are in the included field. And so the issue with that is that it's not nested the way we need it to be for ecto. We actually have to re-nest the data because they made it so it was flat because they wanted it to not be super deep. And the reason they didn't want it super deep is because having that fixed depth means that if you have back references, you don't get an extra copy of the data. So it's a very compact format this way, where you have pointers, the resource identifiers, but you don't have to duplicate the data. A lot of people think this makes it harder for humans to read, but the whole point of JSON API is to be a well-structured, machine-readable format that you can still sort of read as JSON, but it is not meant to be the easiest format for humans. It's supposed to be a very regular format for machines to read. So in order to flip it back to a nested format, we need a lookup table that maps the type and ID, which are the keys used and included, because every entry included is just an array of resources. So the important part that makes each resource unique is the type field and the ID, which makes sense. You know, it's saying like which table to look in and what row to look in that table. However, the lookup table wasn't enough because JSON API allows resource identifiers, or effectively pointers, and it represents has one and belongs to associations the same way as a to-one relationship. So both the belongs to and the has one end up getting relationships with a resource identifier. So they both have a pointer back to each other. See where this is going? We're going to get a circular reference. So in order to track the circular reference, I had to add the third argument, converted by ID by type, to keep track of in this descent, not over the entire conversion, but just down this descent, have I seen this before, to prevent a belongs to and then a has one pointing back and getting a constant loop where it kept trying to do nesting underneath. And so this actually happened where we have our address model as separate from the person whose address it is, but it's a has one relationship. Right now we don't support people having multiple addresses. It's just, you know, a home address. And so the problem is we'd have a person and their address, then the address would refer back to the person that they had. That person would refer back to the address and over, and it just circular. And so I actually successfully blew the stack in Elixir, which is kind of impressive. It usually doesn't happen. If the type and ID have already been seen, then the conversion can't return nothing because that would make it look like the nested association is nil. So you need to differentiate between you didn't ask for the association and it's not there. And so the only way to say that it's not nil, but not to expand it fully, is to just include the primary key. So what it ends up doing is it looks like a resource, it's almost like a resource identifier as a param. So you're like, my address is, and then all it has in the nested structure is ID 1. But the two params behavior only nest params. It doesn't transform the params all the way to the format needed by ecto change set cast, because two params is not past the ecto schema module. At one point, I had these two functions combined, but then I realized they had overlapping concerns. And when I end up having 3 arguments for 2 params where I had to keep track of where's the mapping of IDs and types, and what did I already convert, it just got way too complex. So I separated them out so I didn't have to pass the ecto schema. And this way, the conversion to nested params does not care at all about how this is modeled in ecto. So once the document to params returns the nested params, then I pass those nested params in an ecto schema module as like the primary module. So like as the person, if I'm asking for the person, I'm also getting addresses, to 2 params nested to foreign keys. When it gets a nested param here, so the author ID of like a post, these are some of the canonical examples from JSON API where you're doing a blog. So you know, the post has ID 1, the author's ID 2, and when you transform it, the author ID shows up, and you no longer have the nested author. When the nested params are nil, though, I have to set the author ID to nil, because if I didn't include the author ID, it would be like, oh, you just didn't mention in the request whether there's an author or not. So there were a bunch of subtle bugs about the difference between it's there and it's specifically nil, and you just forgot to load it. This came up a lot when we were interacting with the RPC version of JSON API resources. So JSON API resources only works in controllers, but I adapted parts of the library to work over RPC, and there were times where we forgot to include the references, so it would come back over, and all of a sudden it'd be ecto association not loaded. And so we couldn't tell the difference between whether it was nil or not loaded because of that. And so it was very important to keep track of that with how we propagate nil into foreign keys. So now we have the change set for create on line 73. But once we do the create in mutate repo, we're going to want to potentially sideload stuff. So this could happen where you create a new user and you want to load all of their roles right away as soon as you create them, because you don't want to have to hard code. A new user has these default roles because they might change over time. So you'd want to preload those roles as soon as you create a user. Or maybe you sent an invite token that gave them admin rights right away, and you don't want to backload those rights so that you only act on the data you actually have on the front end. And so on line 74, I convert the params to preloads. And the reason why I do this before the mutate repo, because I don't want to I modified the database, and now I can't actually render the request you asked for. That'd be bad. So this whole structure of like the order that the authorization and the checking the values happen is trying to minimize how many times I hit the database before I find your first error. So I'm not giving you all your errors, but I'm giving you as many errors as I can with as few round trips to the database. And so like the first authorization call in 72 is, in general, can this user create stuff? The second one in 75 is, given the data in this change set, are they allowed to make this change? So this prevents things like users creating a new user that's an admin, or like bumping their buddy up to an admin and that sort of thing. Or just changing a foreign key to all of a sudden switch it over to a different user and spam somebody. Line 31, where we get the fetch structure from params, it can't go wrong because there's no validation. So I don't need to with structure that. But inclusive preloads can error out because we need to pass in which relationship paths, which is what JSON API calls their include structure. So it is dot separated for depth, but comma separated for anding or oring together. And so that could be invalid. So we need to pass that in both. It could be invalid, or it could just be like, we don't want to allow the users to include that. And we really need to say back to the user, we're not going to allow you to load that, because otherwise they're going to say include it, and they're going to think that the user doesn't have those relationships, even though it's just like you're not allowed to see them. This actually did bite us when we didn't do this sort of error handling before, because we kept going, okay, I'm sending this in and I'm not getting anything back. They have an address. Why am I not seeing it? And it's like, oh, well, we didn't support it, but we didn't also tell Ember that it wasn't supported currently. If a relationship path, here secret, isn't defined in the preloads to includes on line 8, so we're just saying an empty map. We don't allow any stuff on the side. We're actually going to return an error. Again, this is the same structure as everything else, where it's a JSON API error document that says it's an unknown relationship path. So this was the change that made it so that we could debug, oh, we haven't implemented that relationship path yet, as opposed to just silently wondering where's the data. So with all that error handling, we have a valid change set. We know we have valid preloads. We feel we can safely change the database. And then the last step is we just use Josterize or Phoenix views to render out documents again. But we don't just use it for API. We also use it on the client. So in addition to using it for the controllers that interface to Ember, we put JSON API inside of JSON RPC and use that to communicate with Ruby applications over RabbitMQ. The reason we keep the structure the same is that way the Rails apps can, or our app, can ask the RPC servers, what would this look like, and pass it right on through to Ember. We do some authorization checks, of course, because role-based stuff is each app's responsibility, because only certain apps know about certain types of roles and that sort of thing. But otherwise, we can just pass it through. The Elixir application has both RPC servers for serving its own resources, one's backed by the database it connects to. So it's, microservice architecture. This app can see this database. Every other access has to be through the RPC server if the backends want to see it. And then it also has RPC clients to get all the resources owned by the Ruby applications. When the JSON RPC response comes back, it has a result field, which is the result argument here to result the document. API deserialized keys does the same thing as the JAWS serializer deserializer plug, but I had to write it by hand and extract out the format keys function from JAWS serializer because unfortunately the deserializer only works on plugs. At least format keys was accessible. There's been a couple times where when I've been doing both the controllers with Phoenix and then RPC stuff where I'm like, if they just would have separated out the module from this needs Phoenix to this does logic, I wouldn't have to duplicate as much stuff. And I don't know, somewhat worried that people are going to be too Phoenix focused on some things, but at the same time, it's an unexpected use case to do JSON API over RPC. So I got to give them that at least. The result to document is using the reply, which is it's going to do a gen server reply call. And so gen server reply happens where you can get a handle call and respond back, I'll handle this later, and store in your state that I need to reply to this eventually. And so that's what we're doing here is the way I made the clients was they are a separate gen server so that their message queue talking to RabbitMQ is isolated from the caller. And that way I don't have to worry about the process getting flooded with stuff that's just RabbitMQ created. I could have done it all in the same process, but I felt this was a cleaner separation. And so reply eventually is going to be used once RabbitMQ gets back to me with the result. But I want the client to almost act like an ecto repo call. So instead of returning a JSON API document, I actually wanted to return a nested ecto schema structure. So document to ecto schema does that. So if we take a JSON API result with no values, we get this document, and then we convert it over, we get back nil, which is what you expect. It's almost like a ecto repo get. If you get with an ID that's not there, you get back nil. That's what this is the equivalent of doing. If you actually have data, with no relationships, you get back what you'd expect. You get back the struct for the types you passed in down on line 24, where you're mapping the type field on line 8 thing to the actual ecto schema module. When there are relationships, they get attached to the struct using the pre-existing associations. This may seem that I'm overly tying the relationships to associations, but none of this code actually cares that there's an ecto repo. The ecto schema modules are only a convenient pre-existing DSL for declaring how to cast certain fields. Because otherwise I would have had to invent my own DSL for this is a date or a timestamp field. This is how you convert it. Ecto already exists. And as the new stuff for Ecto 2 says, it is a way of modeling your data. It is not an ORM. And it works great for this. The relationships I can declare using the association stuff already, and I can do attribute casting with the fields. It so happens, for the API controllers at least, that the ecto schema modules do match our database, but that's mostly a side effect of we don't have complex enough composed views that we needed one ecto schema for the database and one for what the JSON API does. Now, we could do that, and that sort of thing actually exists in JSON API resources on the Rails side, where they have resources as a separate class that's kind of like a presenter that's separate from the active record stuff. It's more important in active record because active record is such a heavy set of API that you kind of do want it separate. At the same time, we have ecto schema modules that aren't in the database because they are just used for the RPC clients. So we have schemas for how to read data that only exist in a database for Rails. And one of the nice things for that is we only have to declare the fields we care about because the rest can just be ignored. Now, this is one place where I debated adding more errors because JSON API resources is very nice where like it will say you sent fields that I'm not going to use, which is great on create. And Alembic doesn't do that right now. It just ignores them. I'm not sure if there's a way to do that that would also let us to asynchronously upgrade the Rails side versus the Elixir side for parsing the resources. So right now I'm okay with it, but if someone has a good design to make it sometimes reject when you don't include the attributes, I'm all ears. PR is welcome. So how document to schema actually works is it calls a module to schema. Most of my behaviors eventually get a module named after themselves, and then they have a function that called that. I don't know if that's normal. It's just the structure I used, which uses ecto change set cast to apply the casting rules defined by the ecto schema module fields. It does not use change set, though. It just uses cast. Because for the use case of a client, there is no validation of attributes and associations because whatever the server sent you is the truth. So I want the casting rules from your fields. I don't want the validation because I want to see the messed up data in all its glory from the server. Like I want to see exactly what they sent, but as a struct.
So you have you to write some additional layer of validation on top of that.
Right, because remember this specifically was I wanted this to work for clients, and the clients just have to take what the server says and assume that they're behind the times if the server sends data that isn't valid, you know, the business rules between the relationships between the different attributes. Because to schema, the function, only uses cast and __ schema __, which is sort of like the reflect on association from Rails. We're able to use the ecto schema module DSL without having to define any extras for the DSL. We don't have to add extra things. We don't have to switch the types you declare. You know, like you would when you use Timex, you have to use Timex's types instead of the built-in ecto ones. None of that's required. We're just using what's already there. The toString on line 113 that's highlighted is in put named association is the only code that cements that a relationship name matches an association name. If people really want that to be separate, it could just be a function you pass in to transform it. But like I said, your ecto schema module that does the casting of the field does not have to be the same as the one that you use to write to the database. You could have another layer that says, okay, here's my resources ecto schema. I'm going to pull out these fields and save it to these parts of the database. That doesn't have to be the same thing. It is for our use case just because it works. So put association, once it gets a name, then has to do the trouble of handling each type of association. And eventually, it's going to call to schema again to do this recursively to handle all the nested associations. I didn't have this working recursively, and the code was actually more complex, and it didn't handle nested associations. So I fixed it. I fixed the bug that did nested associations and actually made this simpler because to schema just handles a lot of stuff for you. So with the available conversion functions in Alembic for both checking documents and handling the includes, we're able to use it for both clients and servers and for API and RPC. While JAWS Serializer mostly works only for controllers because it's dependency on plug. So it works a lot like JAWS Serializer without needing plug con. It leaves the casting associations to ecto without the need for database access and without having to invent a new DSL just for JSON API. Questions?
One of the things that when we were talking about spec, does the spec support a new JSON LD linkage as well? Or reference document?
I don't. JSON API hasn't really changed much unless the 1.1 version had a bunch of updates. it hasn't had updates in a long time. I think they're, so it's a little bit weird in that JSON API came out of Ember, but Ember itself is not JSON API compliant. Like it has things, Ember data can do things that the spec doesn't support. And so they're slowly trying to get the two to be a perfect match of like, Ember is the reference implementation of JSON API. But my understanding is it hasn't gotten there yet, and I don't think it supports the linkage data yet. I know one of the things that was a big debate of like Ember data supports nested create, and there was a long issue about people trying to get to work, and like it works with Ember data, and then they declared like we're not going to support in JSON API because we don't think that's the right route going forward. Instead, what they would want to do is they want you to make a resource that doesn't exactly mirror like your database, where like if you want a nested object, just make a flat form that looks like those two objects combined.
That's what I kind of do for weird situations.
Yeah.
Yeah, I think using the JSON API,
The one usage
resource, we're using active serializers.
Yeah, so on the Rails side, we started with active model serializers, and then one of our developers found JSON API resources, and it gave us so many new things. So like one of the things is similar to how I made a controller with a bunch of actions that would work the same once you had the rest of the JSON API set up correctly. JSON API resources has that where it has JSON API acts as controller, and that you include it, and all your endpoints for show, create, update, and even the weird ones like get related and get relationship and create relationship, those actions are all defined for you. And so the nice thing about that, and it also has routing helpers to do the same thing, is that once you do that, since it's there and it's easy, you don't start creating extra actions. You know, that's always the problem with the routers, of you're creating little off-spec actions that are one-offs. And like having that predefined was kind of nice. And also, you know, active model serializers aren't going to give you all the nice errors when you screw up the JSON API format the way JSON API resources does.
I was maybe wondering if you do the JSON API serializer that active model serializers is also compatible with.
I don't know. So I have not tried that. So the thing with the JSON API spec is there's no spec checker right now, which is so weird.
I've heard talk that it's almost impossible to write JSON.
Yeah, so that's another thing, is because there's relationships between stuff. That just what happened. So we kind of took JSON API resources because I want to say it's almost like 3 years old. It has a really long age. It seems really well tested and gives a lot of helpful error messages as we're going to assume that is correct and use that as our reference of like, if we don't behave that way, then we probably should behave that way because it's probably right. And like a couple times I did fight it with like how to name stuff, and I just was like, no, read the spec. Like, okay, the spec actually does say that. I should do that. The only thing we don't do is like, I made our error messages slightly better, and they're not the same. So it can't be like you substitute behind the covers Alembic and you'll get back the same error messages. Because like I said, one of the things with meta was I made sure the meta was machine parsable to reconstitute a new error message if you want, and JSON API resources doesn't do that.
What is the reason? Well, I don't mean to sound critical. Like, why are you using JSON API over RPC?
Chosen before I started.
Okay, I was just curious, to be honest.
Yeah, but like some of these decisions didn't happen before I started, and mostly it's I write the tool to make it work as well as possible with the pre-existing condition. But I could also make the argument of it's nice that it looks the same on every direction, and it's a pre-existing format. So there are things that'll give you format where you still have to decide the format. You know, like Captain Proto or Thrift, like it says how the individual bits are packed, but it doesn't say like how you render the overall object.
Right.
And JSON API does that, which is why it's kind of nice. Like it's one less thing you have to make a decision about.
That's part of why we went with as well.
Yeah.
We went from a world where everybody handcrafted their own JSON format
Right.
to, okay, at least we have some standards.
Yeah.
Sort of.
Yeah. So that is nice. Like I'm like, wow, this seems overhead. I should try to get BERT to work. Like, oh wait, no one actually uses BERT anymore. You know, the Erlang term encoding, but it works across all the different languages. But then it kind of grew on me like, well, yeah, if you do BERT, you still have to decide, am I sending tuples? Or, well, BERT pre-exists maps, so like it won't even support maps. And so you still have to decide on a lot of stuff about your format. You've decided on the bit level encoding for most of those encoding formats. You haven't decided on the actual structure of how to represent data yet. And so JSON API is higher level, and so it gives you that. So it's kind of nice that way. I skimmed it. I haven't read it through in detail yet. And also, I don't do the front end that often, so I don't know if it would change how we're doing the front end that much. I mean, I don't know if we have multi-form like that. You know, because like her use case was she had multiple forms at once. Although I want to say that would also apply, thinking about now, where you have like, you know, the wizard view where like you have multiple pages of forms. So maybe it'd be helpful there. I'd have to talk with our front end guys about it. Oh, data down, actions up. Yeah, I don't know any of that Ember terminology. I'm totally back in right now. Anything else? Okay.
Have any kind of testing of the resulting serialized format? Like say you know that you want to serialize a blog post and the related data for the person who posted it, verifying that you have the correct keys showing up in the output JSON.
So, yeah. So what actually, every example of that sort of thing that's on the JSONAPI.org website, I make sure it is parsable and I can parse it. So I pass it through Poison decode, then I send that to from JSON, get the structure out. I make sure I can re-encode it with Poison encode, spit it back out, and I can do that all over again without losing any data. And so if you look in the test, there's a thing that does this called assert item potent that makes sure that all that back and forth doesn't lose data.
Okay. So what about me as a user of this hex package? If I want to make sure that I remember to properly declare each one of these different fields that I want to have in schemas, how would you recommend going ahead and testing to make sure that, you know, somewhere in all my shuffling, I didn't lose the slug form of the username?
I don't know. It doesn't really check that sort of thing. You know, because that level of like what are the fields isn't part of the JSON API spec. And for Alembic's implementation, it hands it off to Ecto.
Okay. So you would look at Ecto to provide that?
Yes. Because like right now, that is the library that does casting of strings to other data types. I mean, there may be one that is just that, but like that was the first thing I reached for was I have Ecto as a dependency. It does. Yeah, and Ecto 2 gets, or the casters might be separable from the Ecto schema module because that was part of, like you could do direct queries with cast annotation, with type annotations in the query. That was part of Ecto 2. So there may be a way to do it without an Ecto schema being declared, but the Ecto schema, because of that reflection, is nice for following that the associations are relationships. So it's kind of nice the way it's structured now. Anything else? Okay. Let's see if I can. Okay, broadcast, we're ending now.